Welcome to Engineering Visualization channel. So today we are going to solve the model question number 2 Vtu-Caed. So here in the question number 1 given it is a circular lamina inclined to the VP appears in the front view as an ellipse of major axis 60 mm and minor axis 40 mm. The major axis is parallel to both the HP and VP. One end of the minor axis is in the both the HP and VP. Draw the projection of the lamina and determine the inclination of the lamina with the HP plane. So in this problem we have to use the dimensions of the ellipse, that is major and minor axis. Okay, circle dimensions they have not given and it is occurs in the front view, that is we need to use major axis of the ellipse 660 mm in order to construct the circle. Okay, this is one of the special type of problem. Okay, so in this problem they have not given any kind of inclination. We have to use the data which is given in the problem to solve the problem. Okay, so first we'll be drawing an xy line and writing VPHB. Okay, so here the first position will be in circle, but for that circle they have not given any dimensions, but they have mentioned the dimensions for the ellipse, that is major axis 60 mm and minor axis 40 mm. So the major axis of the ellipse will be the same dimension as that of the circle. Okay, so this is I think the last problems what we get in the solution book. Okay, so that means you can expect any question in the exam, because this time the question paper it is coming from the video. You can expect any problem. Okay, so better to refer all the types of problem with the solution. Okay, here I'll be constructing an circle using center method. So diameter will take directly the major axis dimension here. Okay, so in the question given the major axis it is 60 mm, that means we'll take the same diameter, that is 60. Enter. Okay, now we need to divide this circle into 4 equal parts. So watch the video till the end so you can understand the concept and how to construct in the SolidEdge software. I think this problem I think I have not done in my YouTube channel. So using extend to next command you can extend these lines. Now write down the namings and draw the projection lines downward to construct the top view. Write down the notations and then project the lines downward to complete the top view here. Okay, so if you want the solution of all the problems in the drawing subject, so you can subscribe to my channel and hit on the bell icon for the latest notifications you can get, and share to your friends and classmates in the WhatsApp group so that they also can begin benefited from this. Draw the projection lines downward to complete the top view. So here I am finding little difficulty in this software because it taking too much time to load. Okay, that's why I'm, otherwise I could have done this problem within 10 minutes. As I'm clicking and dragging out, it is taking more time, I don't know. Okay, so first position we have done. Now we'll write the namings of the top view. Last week around 11,000 people have been watched my channel, but out of 11,000 only 150 students have subscribed. So I request the students who are watching my channel, so please subscribe. Okay, so that it will be beneficial for me also. Okay, now in the second position we have to draw the ellipse here because we don't have any kind of inclinations in the problem. Okay, so here the major axis dimensions, it is 60 and minor it is 40. We have to use these major and minor axis to construct the ellipse here in the second position. Then after that we will find out the angle. Okay, so for that what I'll do, I'll be just projecting this major axis dimensions horizontally. Okay, this is also the 60 mm only, the major axis. Then from the middle I'll consider the minor axis distance 40 mm, that is I'll be drawing on the either side by 20 mm. You can see in the question. So minor axis 40 means 20 mm we have to draw on either sides. Now draw the ellipse facing ellipse by center point. Okay, guys, you're having exam after say some 1 month, so you may be forgetting all the concepts. So my recommendation is that you can refer my channel for revision purpose. Okay, because I have done the problems both in sketchbook and in solid software, so that you can revise easily with minimal time. It doesn't take too much time for revision because the problems were done in a very stipulated manner, so that every student can understand it easily, and within very less time you can revise it, because you may be forgetting all the concepts like normal type, beta angle, like that. Okay, so my request is that you can refer, because with respect to the playlist I have created all the content with respect to the Vtu syllabus, right? Projection of points, projection of lines, or it can be projection of planes, projection of solids. Okay, isometric projection and development of lateral surface of solids. So with respect to the playlist, I have created separate playlists. Say for sketching also separate playlist is there, and for this practicing in the system, that is using solid software, so that is also I have created separately. You can refer those videos, so it can be helpful. So no need to worry that you don't have enough time for practicing after the theory exams. You have only say one day. So it's better. What I recommend is that after your theory exam, say not like theory, you can't able to revise in one day. Say in between the theory exams, like you will be. Welcome to Engineering Visualization channel. Today we are going to solve problem number 2 in model question paper 2 of computer aided engineering drawing. Okay, so it will be beneficial for you people who need to watch this video until end, so that you can able to understand each and every step of this problem. And this is one of the important problem, that is problem number 2, that is in projection of solids tetrahedron. A tetrahedron of 50 side rests on one of its corners, such that edge containing that corner is inclined to HP at 50 degree and BP at 30 degree. So this is one of the special type of problem. So in this okay, this so the same problem I have taken from the solution book. Okay, like this we need to construct in the solid software. Okay, this is the same problem we need to construct. So just for the reference I have taken like this, the same thing we need to construct. Okay, it will be easier for me to construct it is. Okay, so go to solid software, draw xy line, write HPVP. Okay, and xy line. Okay, because the problems we are constructing in the first quadrant. Okay, we need to construct this triangular face. Okay, go to polygon by center, make sure the mental relationship should be on, select three sides, thickness 0.50 with respect to edge we need to place it. Okay, same problem has been asked in the model question paper 2. Okay, so give the length 55, enter, it will change. Now draw the projection lines. So here we need to draw median lines. Two medians are enough to find out the center, since it is a tetrahedron. It is one of the pyramids, so we need to draw the all the three slant edges. Okay, now write the namings for it. ABC bow O1. Okay, draw the projection lines upward. Okay, in this we don't know the axis length is this tetrahedron problem. Just randomly you need to draw, and from on this end, from the one end which is parallel to x, so you can see CO, it is parallel, that's why we are cutting the arc from this end of length 55 radius. Cut the arc. Okay, now join it. Guys, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, you are going to get all the problems solved from the model question paper of the Vtu-Caed. Okay, so it will be beneficial for you. You can share this video in your WhatsApp group, so that your friends and classmates can be benefited. So we are writing the front view notations: B dash visible, A dash not visible, O1 dash and O dash. Okay, next in second position, it is nothing but inclination with the base edge here. Okay, now we'll select this front view and go to move command. So here we are rotating, so we need to copy along the xy line, and then we need to rotate and give the angle. So for this base edge, so angle is 50 degree. So it is yeah, this is what the angle we get it. Guys, you follow this procedure. Okay, now project it downwards to complete the second position top view. Write down the notations. So first we need to construct the outer boundary line, guys. In the second position top view, we follow the same steps. So zoom in to get the exact point here. Okay, construct the dashed line as it is in the question. Now we need to find out the beta angle here. Okay, so mention the axis. So here in this problem they have given angle of inclination with the edges here, but the concept of beta angle is that it will be there with respect to axis, but it is one of the special type of problem. Okay, here in this angle of inclination they have given with respect to the edges for both HP and VP plane. That's why it is also the beta angle problem. Okay, angle 30 degree. So minus 150 if you give, it will take 30 degree. Okay, now here the slant edge length you need to use, that is 55 mm. So go to arc by center. So take 55 mm length and cut the arc. Okay, now draw the locus line. So another length we have, that is slant edge 35.16. So these two lengths are required. So one length already we have drawn. Now we need to draw an locus line here, horizontal dashed line. Okay, so cut second arc using arc by center. So just move the cursor on the first arc, you will get the reference point. Now type the radius 35.16 and enter and cut the arc. Now join this second point which I have cut it. Yes, zoom in and get the point. Okay, so just extend this line using extend to next command and find out angle, beta angle. So it is 51 degree. So we're getting an exact angle here, guys. We're doing correctly. Guys, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to your classmates and friends so that they can be benefited. So using move command we have copied. So take the reference point of OC and place it on the angle line here. So place it pinpoint. You can zoom in when you're placing it. You can zoom in and place. Okay, so now draw the projection lines to complete the final position here. Okay, after writing the notations, you can join it first. Join the triangular face and then the slant edges. If any of the slant edges passing inside, that will be dashed line. So passing outside means it is continuous one. So the dashed line from here, from this end to here. Okay, and then finally we need to draw an axis. Okay, that completes the problem. Thank you guys. Thank you all for watching the video. So subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you all. Welcome to Engineering Visualization channel. So today we are going to solve question number 3 in the model question paper 3 of Vtu-Caed, computer aided engineering drawing. Okay, so make use of the video. You can watch till the end. You can able to understand each and every step of the problem. So here the problem number 3 of the model question paper 2, it is nothing but isometric problem. Here the sphere of diameter 50 mm rests centrally on a cube of sides 50 mm. Draw the isometric projection of the combination. It is nothing but the problem number 1. Okay, so you can see in this question, so we need to construct a cube. Above it we need to construct the sphere here. So first I'll be drawing an reference line. So please follow the step by step. You can able to understand the problem clear and easily. Okay, so reference line drawn. Okay, here we need to construct the cube first. So this cube of sides 50 mm. 50 mm means we need to consider 50 mm box. So here please consider the angles. So from this reference end, length will be 50, angle is 30 degree. Okay, again length is 50, angle is 180 degree, 150 degree, sorry. Then another angle is, again length is 50, angle is 210 degree. So like this we need to construct the box. Okay, now vertical height we need to give the height of 50 mm. One line I will draw, length of 50 mm. Okay, then go to move command, creates a copy of it, or either you can directly do it like this. Okay, length 50 mm directly we can do. Angle is 90 degree. Okay, now construct the top face. So here the cube construction it is done, guys. The cube we have constructed. Above it centrally we need to place the sphere here. So that is also having dimension 50. But guys, you know that sphere will be constructed with the actual scale, but the cube we need to convert into isometric here. Okay, so that is the important thing you should. Okay, you can keep it like this. Then you can show the angle. And this is one of the basic first problem of the isometric projection, guys, and this problem can be asked in the exam. Okay, so find out the midpoints. Height we need to find out. This is the center of the box. Center of the sphere will be find out. The height will be 25. Okay, now after finding out the height, we will convert into ISO. Okay, so this step you remember, guys. Go to scale here, type here 0.816 or 823, can type it. Okay, now go to circle and draw here. That's what the center of the sphere. Now go to circle and draw circle of diameter 50. Enter. So that completes the sphere here. So always remember, sphere will be drawn with the actual scale, other solids will be converted into ISO. So you can check the dimensions here. This will be 50 sphere actual dimensions, but if you check the dimension of the cube, it is less than 50. But after converting to ISO, it is converted into less dimensions. Okay, thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you, guys. Thank you all. Welcome to Engineering Visualization channel. So today we are going to solve problem number 4, that is development problem in model question paper 2 CAD. Okay, computer aided engineering drawing. Okay, you can watch the video till the end. You can understand each and every steps of this particular problem. So we are solving the problem number 4, that is development square pyramid problem in model question number 2. You can see square pyramid given, base 40, side and axis 60 mm long, has its base on HP and all the edges of the base are equally inclined to VP, and it's cut with an inclined plane 6. Okay, the same question which I have taken from the solution book. Okay, here it is easy to study and do the solution. Okay, we cannot just go and back like that, so that's why I have taken like this here. So here first we need to construct a square pyramid of base 40 mm and axis 65, and it is resting with edges of the base or equally inclined to VP. Equally inclined to VP means it is nothing but resting with the corner position. Okay, and then it will be cut by a section plane. So first we construct the top and front view of it, and then the section plane. Okay, step by step we are going to do it, so please watch it till the end. You can understand all the steps, okay, easily. So go to rectangle by center. Here the width and height we have to give, that is 40 and 40, and angle will be 45 degree. So this is how we construct the square with respect to corner position. Okay, show the dimensions and write down the namings for it. Write xy HPVV and draw the projection lines upward to construct the front view. So here top view notations can be written ABCD. Since it is a pyramid, that means we need to draw the slant edges, that is thick lines we need to draw here. If it is a prism, means it should be thin lines. So you all should know this difference. So thick lines we have drawn. Write down O1. Okay. Now draw the projection lines upward to construct the front view. So projection line should be thin line, that is 0.13 mm. We should take thickness. So axis height is 65 mm. Take the same length. So construct the triangular face. Show the dimension of the axis. So front view it is done. Now here we need to draw an section plane, that is truncated surface at an angle of 40 degree. Okay, so exactly midpoint we need to find out, because it is bisecting the axis, means exactly half 65 half is 32.5. So here at this point we need to draw an section plane at an angle of 40 degree. So the length can be anything, but here angle you have to show with respect to axis. It is given in the question, it is 45 degree, guys. So it exactly this, right? So this is a section plane. Now can mention the, so that upper portion I am going to make it okay lighter in order to show that the lower portion has been the cut portion, the truncated surface. Okay, now I'm mentioning the cut points here. So it is cutting the, so you can mention this front view notations: E dash, B dash, C dash, and D dash is not visible from the front view. O1 dash and O dash also can mention. Now I can mention the cut points. So here cut points we are mentioning with the numericals. So 1 is cutting the slant edge AO, 2 is cutting the slant edge BO, and C is cutting the slant edge CO, and 4 it is cutting the slant edge DO. Okay. Okay, mention the cut points like this. Then measure the slant edge dimension. So here you need to find out the slant edge dimension. Use 2 points. So here in the dimension they are showing horizontal, vertical, right? So this length also you can take it, because that is also a slant edge length. Okay, just for reference I'm drawing the slant edge here because I have split it there. Okay, now we're getting the slant edge length, same length we got it. Now using this slant edge length we will construct the development of it. Same for same length we'll be drawing a line. Now we need to transfer all these cut points on the slant edge length. Okay, 1 and 4, this is important step, guys. You should do it. 2 and 4, and this is 1, 3 it is already there on the slant edge. Okay, and you need to measure this length because we need to cut the arc on the slant edge when we are drawing and this development, right? We should know these dimensions. The slant edge lengths we need to find out. So for this I'll be using split command to get the exact length here. Okay, so in the distance between command there is an option here. So distance between 2 points, if you select, so you can able to measure the dimension. Okay, this is important step, guys. You can make use of this particular command. So select these 2 points, this will give the slanted line. Same way from this end to from this end. So again you have to select this particular command. Again you need to yes, like this you can measure. Yes, we got all the section point length on the slant edge. Now we will construct the same slant edge length here. After drawing a vertical line, we need to draw an arc using curve by center command. Okay, use arc by center command here. Yes, center point and then draw an arc. Again here we need to use the arc again because 40 mm length we need to cut. Guys, in order to solve this problem it takes a lot of effort, so please make use of this video and subscribe to my channel and share to your friends and classmates so that they can be benefited. I am solving this model question paper because many of the students have been requested me. That's why I'm doing it. If you found this video very helpful, you can super thanks. There is an icon in the YouTube as you are watching the video. There is a little bit like sharing like button, but after that there is a particular icon like heart wherein you can, if you want to donate to this particular channel, you can donate it by super thanks. It starts from say 40 rupees. How much you want to pay, can do it, there is no problem. If you found this video helpful, you can do it. Okay, you can join like this. Connect all the arc cut point which you have cut it, right, using vertical lines. Okay, like this you can connect it. If you're finding any disturbances during the video, so you can neglect it, so concentrate on the video so that you can able to practice it. Okay, so like this you can construct because it is having four since it is a square pyramid. Okay, so join it like this. So dimension we can measure it and give the naming for it: capital B, capital C, capital D and capital E. Okay, and A again. Now the cut points we should mention the dimensions which I have already measured for on the slant edge. Okay, A1 the same length arc we should cut. Similarly for 2 and 4 it will be the same length, and for 3 it is the length which we measured. Okay, go to arc by center and type that same radius for